Hi, welcome to this lesson on number patterns, sigma notations. Let's have a look at solving a sigma notation problem, question 1. Expand out the sigma notation and calculate the series. So there's two ways we can go about this. Because of the bracket placements, and I know the properties of brackets, I can first expand it out as follows. So I'll start at n equals 1. So wherever there's an n, I'll replace it with 1. So 2 times 1 squared plus 1. Summation says add. Now start at n equals 2. 2 times 2 squared plus 1. For n equals 3, you'll have 2 times 3 squared plus 1. Plus n equals 4, you'll have 2 times 4 squared plus 1. All the way up to the fifth term, which is the upper bound. That's where you end. 2 times 5 squared plus 1. So let's go ahead and add that up. 1 squared is 1, times 2 is 2, plus 1, that's 3, plus 2 squared is 4, times 2 is 8, plus 1 is 9. 3 squared 9, times 2 is 18, plus 1 is 19. 4 squared is 16, times 2 is 32, plus 1 is 33, plus 5 squared 25, times 2 is 50, plus 1 is 51. So let's try and do a little mental arithmetic. Let's try not to rely on the calculators too much. So what I see here, 51 and 9, those together add up to 60. 3 and 33, those add up to 36. And what haven't we added yet? The 19. Okay, and again here, 60 plus 36, that gives me 96 plus 19. I know 9 and 1 here is going to give me 100, and 6 plus 9 is going to give me 15. So in total, I have 115 from that summation. The other way I could have done it is first use the sum law, which says I can break apart that general term in brackets there, 2n squared plus 1, as follows. I can take it as the sum from n equals 1 to 5 of 2n squared, plus the summation of n equals 1 to 5 of just 1. Okay? And then for this first term here, I can use the constant law by bringing out this constant 2 outside. So 2 times the sum from n equals 1 to 5 of n squared, plus the sum from n equals 1 to 5 of just 1. Now, this first term here, I just have to worry about the summation of the n terms. So that's going to be 2 into 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. That's where I end. Plus, now this is the summation of just 1 from 1 to 5. And we saw that from either the first summation formula or even from the summing constants law, that this is just going to be 1 plus 1 plus 1 plus 1 plus 1 5 times. So it's 5 times 1, which is just 5. So if I do that, 2 into 1 squared 1 plus 4 plus 9 plus 16 plus 25 plus 5. So let's again do some mental arithmetic. I'm going to see 1 plus 9 is 10, 4 plus 16, so 1 plus 9 is 10, 4 plus 16 is 20. So I have 10 plus 20 plus 25. That works out quite nice, plus 5. Then here, it's going to be 2 times 30, 55 plus 5. 2 times 55 is 110 plus 5, which is 115. Do I get the same result? Yes. So that means that our summation is correct, doing both ways. Just as a nice bonus fact, if you have a calculator that actually has a summation button feature, so on the newer Casio models, you'll see above your log button, there's a little summation button there. So if you click shift and log, you can see you have the summation coming out. And we can write it exactly the way we see it. So X is wherever your ends are. So it starts at 1. I press up and I go to 5. I press right again to get inside the brackets. 2, now I need an X, so I'll press alpha and look for the X, and then I need to square it. And lastly, add 1. So if I push equals there, brilliant. So that's a nice way to fact check your answer as well, using the summation property on the calculator app. Okay, so that is how we will solve this problem. I'll see you in the next one.